In this video, I want to discuss Programming Assignment 3 and show how it's very similar to the example that we're doing in our class. So I recently put together this kind of class diagram, and we're going to see something very similar for Assignment 3. So in this assignment, we are essentially simulating a bank account and some bank account information. Now, remember the concept of inheritance and also extending classes. The idea is that we start with a superclass, which is kind of an abstract concept, and then we can define that in a series of subclasses, where the subclasses extend the superclass, and the subclasses inherit attributes and methods of the superclass, provided, number one, that those methods and attributes are not, or methods and attributes, yes, are not private, and number two, the subclass has an opportunity to override a method from the superclass. In other words, the subclass can define its own behavior. So let's read through this program and let's think about what a class diagram might look like. So we want to do we want to prompt the user for some information like a beginning principal, rate of interest per period, and number of periods. Well, that sounds a lot like our driver class, doesn't it? Because we have a prompt user method. So why don't I make a new class diagram over here so we can kind of do a comparison. And inside of this, what class is going to do all that prompting? Well, let's see. You must prompt for a beginning balance, rate of interest, number of periods, so on and so forth. Do this from the banker class, not from any of the account classes. So I scroll down, and I see there's a class called banker. All user input and output should occur in this class. There should not be any JOption pane show input dialog and saving CD or checking. Okay, so it's a class called banker. So I hit my little kind of a cheeseburger here, and we're going to call this one banker. And banker, we're going to add a new method, and that new method is going to be, guess what? Prompt user. So you see it already looks very much like our driver class over here because this is where all of our input and output goes. So how do we draw the rest of this then? Well, let's scroll back up a little bit, and let's see. Create a project named Calculator in your IDE. This will be a package for your classes. Okay, so we know that the package should be Calculator, just like so. Okay, and make a class hierarchy that contains the following classes. Class account, accessible attributes. Accessible means it's not private, so it's public or protected. Should be at least principal, rate, and period. And accessible methods should be at least calculate. Okay, so I need to make a new class called account. And we say it's going to have attributes, so I can do add, and then we can say attribute. And we said principal. Maybe a little easier if I drag it up this way just a little bit. There we go. So we'll call this one principal. Okay, and then we know we need to add another one. And the next one we're going to call rate. And rate probably shouldn't be an integer. It should probably be some kind of floating point type like double because rate can be fractional. So principal, rate, and then a number of periods. So let's do one more of these. And this one we'll call periods. And periods can be an integer. That's fine. Now, we said that it also requires a method called calculate, and the method called calculate should have this formula inside of it. Principal equals principal times rate plus principal. That sounds a lot like the method go in vehicle. And miles per gallon, odometer, gallons of gas sounds a lot like principal, rate, and periods in this class called account. So go is like a method called calculate. So let's add a new method. I hit this operation here, and we're going to call this calculate. And there we go, looking good. Now we know that we're going to do all the input and output from banker, and account is going to hold all the data. So let's make this uses our relationship with a solid line, and now we can continue looking at the rest of the program. Okay, class savings extends account. It should inherit attributes from the superclass account. In other words, do not redefine, or in other words, do not redeclare them in savings. Accessible methods should be at least calculate. You should inherit this method. You do not need to overwrite it. So if we go back to our UML, just like we have a Neon as a basic vehicle that has nothing special to it, savings is kind of like a default account. All we need to do is create this subclass called savings, and it is going to inherit everything from account. It doesn't need to define any additional attributes or any additional operations. So the savings class should be very small. Really, all we're doing is defining a very basic account. Okay, class checking extends account, so it should inherit principal, rate, and periods, but it is going to have a couple of additional attributes, check number and monthly fee. So you see this one sounds a lot like, actually it sounds a lot like Prius, because it's going to have some additional computations here. So let's click on account, and boom, and this one we're going to call checking, and we'll give it a few new attributes. So just like so. And this one we'll call check number. And also we'll add one more attribute and we'll call that monthly fee. So check number and monthly fee. So check number assumes that you used to be able to order checks and say what your starting check number was, because a lot of people would not accept a check with a loan number, thinking it's an account you've just opened and you're just about to close, and you're going to write a bounce check from it. Okay, now note that this should contain a method called calculate. It doesn't say inherit, it says should contain a method named calculate. So in this case, we are overwriting the method called calculate from the superclass. Because we're overwriting, I need to have a method with the same signature in my subclass checking, so I'm going to call this one calculate. This is the only one of the three subclasses that's going to override that method calculate. The reason why it's overriding the method calculate is it needs to subtract a monthly fee for having a checking account. So I'll make this a little bit bigger. So it's going to have a bit of special logic in its calculate method, just the same way that a Prius is going to have a very special go method, because it can either use the internal combustion engine or it can use the battery. So checking is going to have a special calculate method to remove that monthly fee. What else do we have? Certificate of deposit extends account. It should inherit principal, rate, and period, so we're good there, but it should define locally a method called length. Now, why is that? Well, certificate of deposit usually pays a higher interest rate, but you have to keep your money in the CD for a certain amount of time, and that's what the length is. Now, don't worry about including length in any kind of interest calculation. The periods that we already have is what's going to do that calculation. We're just collecting this information from the user. What is your length to maturity? Good news here, though. We are inheriting the method calculate, not overwriting the method calculate, so we don't need to make a separate method called calculate. So we go here, and I extend one more time, and we grab this and put it inside. Whoop, wrong one. Grab this guy as delicately as I can and put it inside. And we'll call this one certificate of deposit. And attribute, we simply need to add one more attribute that we're going to call length. And integer is just fine. So if you take a look at CD, let me size that, get that a little bit better sized. CD looks a lot like Cavalier. A Cavalier is a neon with one extra attribute. A CD is a savings account with one extra attribute, which is length to maturity. We already know that checking looks a lot like Prius because it has two extra attributes, and it is overriding the calculate method, where the other two subclasses are simply inheriting that method. So consider this when you go through the videos where I'm doing this extension relationship, because that plays right into our programming assignment 3. Of course, don't forget to zip up the entire program and fill out the grade sheet so I can maximize partial credit to you, and take a look at the Blackboard calendar for official due dates. Good luck. Let me know if you need any help. Thank you.